Hello there, this video is going to be a quick review, a lesson 4.1 to 4.3 before you take your quiz. So one of the first things that we were talking about in this particular chapter were vectors and how we do the notation for vectors. So if I start with a vector here and I go all right, so if this is the initial point A and this is B, so we would write this as vector AB because we always start with the initial point, and remember it only has one arrow on that. All right, so now if we talk about putting this vector in component form, remember we always go horizontal first. So horizontal, we're going over 2, and component form, we're going to put these marks here. So 2 comma over 2, and then we up 1, 2, 3, 4, 5. So component form of this vector would be 2 comma 5. Now finding the magnitude is really saying find the length of this particular vector. So how would we find the length? Well, to find length, remember that we need 2 endpoints. So don't we have one endpoint here at 0, 0, and we have another over here at 2, 5. So can you find the distance from that ordered pair 0, 0 to 2, 5? So can you use the distance formula and do 2 minus 0 quantity squared plus 5 minus 0 quantity squared. So 2 squared is 4 plus 5 squared. So we're going to have the square root of 29. So grab your calculators, and second square root 29 is going to be approximately 5.4. So the length of this vector, the magnitude of this vector would be 5.4. So remember, when we're talking about a vector, it has magnitude, okay, because it has both length and direction. All right, one more thing I want to talk about on here, but I'm going to get rid of all this. Let's just say that we have a vector on here, and the vector goes down here, and we're telling you that this right here is 30 degrees, okay? So what is the angle or direction that this is at? And remember, we always do it from the horizontal line counterclockwise. Okay, so basically for this one, we could certainly add everything up, or we can take 360 minus 30, and we can say that this would be a 330 degree angle because we measure from the horizontal going counterclockwise to get that. All right. So in this, we already talked about transformations and that the pre-image to the image has the primes, and that it is a rigid motion or isometry. So with our transformations, we talked about translations, and this is an isometry. It has a rigid motion, and the rules for the translations. So we would write this x comma y, and this would be something like x plus 2 and y minus 5. So if I had a and it was at 7, negative 2, where is a prime going to be? Well, I'm going to do 7 plus 2 and negative 2 minus 5. So a prime is going to be at 9, negative 7. A composition of translations would just be 2 translations happening. So a composition is 2 or more. Reflections. So we had different kinds of rules when we were reflecting. So make sure you look up your x-axis rules. So remember, if it goes over the x-axis, x stays the same and y changes signs. When you reflect over the y-axis, y is going to stay the same and x is going to change. When we go over y equals x, then it's going to be, remember x and y switch, so we have y comma x. And then the last one would be y equals the opposite of x when we're going to reflect over that line. So this would be a line going this way. This last one is a line going this way. And this one's going to be the opposite of y, the opposite of x. Remember, lines of symmetry in a polygon, so we reflect over a line of reflection. A glide reflection is going to be a slide and then a reflection, so it is a composition because it is two or more things, so it's going to be a glide then a reflection. The line of symmetry is when you take a regular or any kind of figure, it doesn't have to be regular, and if do you have any lines of symmetry, a line that you could fold it over onto itself, so this rectangle would have two lines of symmetry. And then we practice writing equations after reflecting a line. Remember, they always have to be perpendicular to that line, and that distance needs to be the same. All right, rotation. So having a center of rotation, your angle of rotation. So remember, whatever angle you are reflecting, if it's a 30 degree, you would draw from that to the point and then mark off 30 degrees, and that is where A prime would be. And you do that for every single point. So remember, we had 90 degree, 180 degree, 270 degree rotations here. And so everyone has its own rule. So a 90 degree, remember a 90 degree rule is going to be the opposite of y, x. The 180 degree rule is going to just be the opposite of x, the opposite of y. The 270 degree rule, 270 is going to be y comma minus x. Okay, if a figure has rotational symmetry, so if you think of ceiling fans, and if a ceiling fan has 5 spokes, can we rotate that at all 180 degrees or less, and it would look exactly the same thing? So if we take 360 and we divide by 5, we end up with 72 degrees. So if we rotated this 72 degrees, that it would fall on top of itself. Now, if you multiply that by 2, we have 144 degrees. So less than 180. So it has rotational symmetry of 72 degrees and 144 degrees. All right, hopefully this is a little bit of a review before you take your quiz.